Madam, yes, madam. Yes, madam. Can we start? Good morning to all of you. Today's session on subject business statistics will going to start very soon. Yes, madam already joined, but her voice is not yet. But I think wait for her network. Maybe there is a network issue.
Hello, sir. Your
Yeah.
voice is not
One
Okay.
audible.
second. Hello.
Yes. Yes. Who is speaking?
So myself, Shreya, your voice was not audible.
Yes. Wait. Ma'am will start.
Okay, sir.
Be in proper network. All the students. I am not conducting today's session. Usma madam will be conduct today's session on business statistics. Usma madam, please.
Hello.
Ah, yes.
Am I audible?
Yes. Yes,
Hello.
ma'am. Yes, ma'am. Usma ma'am. Usma madam.
Hello, student. Within a 5 minutes, we will start the lecture.
Okay. Ma'am will start within 5 minutes. Be connected. Everyone need to fill attendance from feedback form for every lecture. For today's session will be start at 12:30. Second session, which will be managerial economics by Vaibhav Patil sir. So slight changes in the timetable. Instead of IT subject, we are going to the managerial economics subject. Just for fine information. If you have questions, please ask regarding anything. Still, ma'am will start full time. If you have any question, please ask. Put yourself and ask the question. Please note, everyone should submit their ABC ID in the Shivaji University Kolhapur as well as Your TCMC is mandatory, so kindly submit it. Those who are already submitted, then they cannot need to resubmit that. But those still not submitted TCMC or ABCID, kindly submit it because further processes are going on. Your examination schedule will become very soon. Assignments also coming. So for the purpose of assignment, we will conduct special session. Okay, thank you. We are waiting for ma'am to start. Ma'am will start very soon. Thank you.
Sir, in
Yes,
5 minutes, we will start the lecture.
yes, ma'am. Yes, ma'am.
Hello, dear students. Good morning. I am Ganga Bhosle. In today's lecture, we will learn the business statistics, and the topic name is diagrammatic and graphical representation, measures of central tendency and measures of dispersion. First, we will see the introduction. Statistics is not a new discipline. Statistics is in use from the time when man began to count and measure. In ancient days, the role of statistics was limited to data collection and interpretations. Later on, statistical methods were developed to analyze data and interpret. Now, statistics has become the most applied branch of science, which is fully developed. Statistics is treated as a branch of science which deals with collection, presentation, analysis, and interpretation of the numerical data. Statistical investigation is a scientific process of collection of necessary data to reach to reasonable interpretation of a problem on the basis of analysis of statistical data. Now we see presentation of subject matter. Diagrammatic and graphical representation. Statistical analysis most often requires diagrammatic and graphic representation of information obtained from data sets. Diagrammatic and graphic representation facilitates comparative study of two or more data sets regarding their shape and pattern. Now we see the concept diagrammatic representation. Diagrams or charts are important tools for the representation of data and its analysis. Diagrams are visual aids for representations of statistical data and are more appealing and fascinating to the eye and leave a lasting impression on the mind. Charts help in better understanding of a situation where, when compared to numerical data, the most commonly used diagrams are First one is bar diagram, second subdivided bar diagram, third multiple bar diagram, and fourth one is pie diagram. Now we first see the bar diagram or simple bar diagram. In this, in order to represent data related to a single variable, a bar diagram is used. In this case, rectangles of equal width and height proportional to the value of the variable are erected on the horizontal axis. It is used to represent the summary values of categorical variables like gender, age group, social categories, etc. Now we see the first problem. Here in problem, represent the following data using simple bar chart. Now we see the data. Hmm? Okay. Now we see the example of bar diagram. In this example, we are given that year and production in million tons. Here is year,
Ma'am, voice is not clear. Ma'am, voice is not clear.
just a minute. There is something problem in digital slate. So wait for 5 minutes. Okay. स्टुडंट, आपण एक 10 मिनिटाचंच लेक्चर व्यवस्थित कंटिन्यू करूया.
Yes, ma'am. Yes, ma'am.
Okay, okay, ma'am.
Hello students. Now we see diagrammatic representation. In this diagrammatic representation, first one is bar diagram or simple bar diagram. In order to represent data related to a single variable, a bar diagram is used. In this case, rectangles of equal width and height proportional to the value of the variable are erected on the horizontal axis. It is used to represent the summary values of categorical variables like gender, age group, social categories, etc. Now we see the problem first. Represent the following data using simple bar chart. In this bar chart, we are given that year and their production in million tons. Okay, and in this first one year is 1995 to 1996. There is production is 40 million tons. For year 1996 to 1917, there is production 45 production in million tons. For 97 to 98, there is 50 tons. For 98 to 99, 55, and 99 to 2000, there is 44 tons. Now, for this following data, for this data, we have bar diagram like this. This one is bar diagram. For 1905 to 96, there is 40. There is, for bar diagram, there is first we have x-axis and this one is y-axis. For x-axis, we are given the years 1905 to 1906, 96 to 97, 97 to 98, 98 to 99, and 99 to 2000. And on y-axis, we are put the values in tons. And this represented by we 0, 10, 20, 30, 40, 50, and 60. For 95 to 96, there the given value is 40 tons. So, we are put there 40 tons here. And for 96 to 97, 45. There is the value in between 40 to 50. This one is 45. For year 97 to 98, their value is 50 tons. So, for on y-axis, we put the value 50. Okay. This one is bar diagram. Now we see subdivided bar diagram. This one likes subdivided means that we have divide two parts. This one is, all of you see, there is first year. In this example, we have given that first year, and this one is divided in two parts, 300, 200, 250, 150, 220 and 80. Now, joint or multiple bar diagram. For this, there is joint or multiple bar diagram means that two bar diagrams are joint, like this, English, boys, girls. This one is subdivided or joint or multiple bar diagram. Now pie diagram. Pie diagram is like this, like a circle. Okay. Now we see graphic representation. In this graphic representation, there is a histogram, frequency, density. In this frequency density, there is a formula for frequency density is class frequency divided by class width. There is a problem. Draw histogram for the following frequency distribution. There are given classes and their respective frequencies. For these classes and frequencies, there is a diagram like this. Okay. Now we see advantages and limitations of graphs. There are some advantages and some limitations. Okay. Now measures of central tendency. In this measure of central tendency, there are the 5 measures of central tendency that are commonly used are, first one is arithmetic mean or simply mean. Second one, median, mode, geometric mean, and last one is harmonic mean. These concepts are very important in statistics. Now, arithmetic mean, the main concept. What is the arithmetic mean? Arithmetic mean is sum of the observations divided by number of observations. There are some cases. First one is individual observations or ungrouped data. For this ungrouped data, arithmetic mean, the formula for arithmetic mean is x bar, and x bar is equal to x1 plus x2 plus dot 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 up to xn and whole divided by n. That is the number of observations, and this in numerator x1 plus x2 plus up to xn is represented by summation from I is equal to 1 to n xi, and the formula is for arithmetic mean is summation I is equal to 1 to n xi whole divided by n, and this summation I is equal to 1 to n xi will be written as summation xi. And for discrete frequency distribution, there is some classes and their respective frequencies are given, and for this class and frequency we have here the formula. Arithmetic mean is f1 x1 plus f2 x2 plus f2 fn xn whole divided by f1 plus f2 up to fn, and this one is represented by summation I is equal to 1 to n fi xi whole divided by n, and n is nothing but summation I is equal to 1 to n fi. Third case is continuous frequency distribution, and this one is represented by summation fi xi whole divided by capital N. Now, there are some properties of arithmetic mean, and deviation. Deviation is if xi is ith observation and a is any constant, and for this the deviation is represented by xi minus x bar, and x bar is nothing but our mean. Now, we see the concept, just a minute. If x1 bar is the arithmetic mean of first group of size n1 and x2 bar is the arithmetic mean of second group size n2, that is mean we have given two means. then we represent this by the formula n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Now we see in first one example. Here in example we have given that the mean of intelligence quotients, that is IQs, of 8 students, which are given that 80, 110, 120, 88, 95, 100, 105, 85, 102 and 112. We have calculate the mean, and what is the formula for mean? This one is x bar is equal to summation xi divided by n. Here the value of n is 8. Count 80 up to 112. This there are, we have given, we are, just a minute. Here the value of n is 8 and summation xi is 82 up to 92. We have add these terms, then we get here 792, and when we divide 792 divided by 8, we get the value 99. This is our mean. Okay. In second problem, we are given some classes and their frequencies. In classes, their number of calls, that is 0, 1, 2 up to 7, and their respective frequencies are 12 up to 14. With this represented by a table, and in this table, we first column is xi, second one is fi, and we calculate for mean fi xi, that means fi into xi. Therefore, we draw the third column is, that is fi xi. Put out the values xi 0, 1, 2 up to 7 and fi 12 up to 14. Now fi xi, that means fi into xi, 0 into 12 is 0. Calculate all these terms. Then we have add these terms. Then we get the value of fi xi, that means summation fi xi is 864, and the value of n, that is summation fi, is 225. And when we divide these terms, we get the arithmetic mean, that is mean number of calls per minute, that means is 3.84. Okay, this one is also same problem. Okay, and in this third example, we have calculate standard deviation method, and for this standard deviation method, we have the formula, that means is ui is equal to xi minus x bar divided by n. Okay. Step deviation method. In this step deviation method, we have first calculate some u bar. Okay, and for this u bar, we have used the formula summation fi xi divided by n, that is 30 divided by 100, which is equal to 0.3. And for this ui xi minus 25 divided by 10, which implies that when we cross multiply these two terms, we get xi is equal to 10 ui plus 25. And from this equation, we get the value of x bar, that means 28. That is mean marks of students are 28. Problem 9 is for there are two means and two values are there. So we use the formula x bar is equal to n1 x1 bar plus n2 x2 bar whole divided by n1 plus n2. Put out these values in this formula, we get the final answer. Okay, there are some merits and demerits. Now we see the concept median, that is the median of the data is the value of the central item when they are arranged in ascending or descending order of their magnitude. In the concept median, there is important ascending or descending order. For this computation of median, we use the formula median is equal to the size of n plus 1 divided by 2th item when n is odd, and when n is even, we have used the formula the size of n by 2th item plus size of n by 2 plus 1th item whole divided by 2. Okay. Now we see the example median of the values 25, 20, 15, 35, 18. First, we have arranged these terms in ascending or descending order. We are arranged in this ascending order. We get 15, 18, 20, 25, 20, 35. Here the values of n is equal to 5, which is odd. So we use the formula median is equal to the size of n plus 1 divided by 2, n plus 1 divided by 2th item. Here the value of n is 5. So we get the answer, the size of 5 plus 1, that is 6, and 6 divided by 2, that is 3. Third term is, what is the third term? 15 is 1, 18 is 2, 20 is third term. So we get the median of these values is 20. Now, and for in second example, there is n is equal to 6, which is even. So we use the formula, the size of n by 2th item plus size of n by 2 plus 1th item whole divided by 2. The value of n is 6. Put out this value of n is equal to 6 in this formula. We get the answer, the size of third item plus the size of fourth item. The third item is 20 and the fourth item is 25. When we add this term 20 plus 25, we get 45. 45 divided by 2, we get the final answer is 22.5. Okay. Now, for median of the frequency distribution, when the classes and their, the value of xi and the value of fi are given. When in this example, we have to calculate the median. For this, we have to find out first the value of capital N, and for this we have given in column xi values, first row xi and second row is fi. Put out these values in table 1, 8, 2, 10 up to 6, 15. And how to calculate capital Fi? First, put out the value as it is, Fi 8. Then cross add these terms 8 and this one is 8 and this one 10. Add these terms, we get the answer 18. Now this 18 add in 11 the value of Fi, then we get the answer 29. Then 29 plus 16 is 45, 45 plus 20 is 65, 65 plus 15 is 80. This one is nothing but our value capital N, which is 80. Now here the value of N is 80 is even, so N by 2, that is 40, N by 2 plus 1 is 41. Then median is equal to N by 2 value plus n by 2 plus 1th value, that is 40 plus 41 whole divided by 2, which is 4. Now this one is same example. Now we see the median for continuous frequency distribution. For this continuous frequency distribution, the formula for median is MD is equal to L plus H by Fk into N by 2 minus Fk minus 1, where L is lower limit of median class, frequency of the median class, H is width of the median class, N is total frequency, and Fk minus 1 is cumulative frequency of the class preceding of the median class. Okay. This one is graphical method of determination of median. Now we see the example. Calculate the median wage for the following frequency distribution. There are some given wages and their respective number of labors. For this, wages 20 to 30. Okay. Now LCF. Now how to calculate this LCF? Same as these 3, put out the value in same 3. Then add these terms, 3 plus 5 is 8, 20 plus 8 is 28, 28 plus 10 is 38, 38 plus 5 is 43. So we get the value of capital N, that is 43, and 43 divided by 2 is, that is 43 is odd number, so we get here N is odd. So 43 divided by 2 is 21.5. Now we put out these all values in the formula. Median is equal to L plus H by Fk into N by 2 minus Fk minus 1. When we calculate these terms, we get the final answer is 46.75. Okay, this one is same. Now mode. The concept mode. Mode is the value which occurs most frequently in a set of observation and around which the other items of the set occurs with cluster density. For this mode, we use the formula M0 is equal to L plus in numerator H into Fm minus F1 divided by 2Fm minus F1 minus F2, where all these terms are L, H, Fm, F1, F2, as you are see in this your sim material. Now frequency, polygon, merits, demerits. This one is our theory problem. So we just see the problem, how to calculate the mode. In this problem, we have given classes and their respective frequencies. In classes 0 to 10 up to 70 to 80 and their respective frequencies 5 up to 10. We just put out the value of all these L, H, Fm, F1, F2. This one is now L is here. First we have in this frequency the maximum value 5, 8, 7, 12, 28, 20, 10, 10. What is the maximum value? Here the maximum value is 28. Okay, that is frequency and their respective E class. This one is 40 to 50 is our model class. So here the value L is equal to 40. H means what? H is the difference between these classes 0 to 10, that is 10 minus 0 is 10, 10 minus 20 minus 10 is 10. So we get the value of H is 10. Now Fm. Fm is what? What is the Fm? Just a minute. Fm is frequency of the model class, F1 is frequency of the pre-model class and F2 is frequency of the post-model class. In this example, we have the model class is 40 to 50, okay, and this our maximum frequency, that is 28. So we get the value of Fm is 28 and F1 is nothing but our pre-model class. Pre-model class is means what? Is this 12. Okay, and the value of F2 is, that is means post-model class, that is 20. Okay, so put out all these values, the value of L, H, Fm, F1, F2 in this formula. And whenever you calculate all these terms, we get the final answer of mode. Okay. For second example, in this second example, we have to calculate the value of, that is frequency. Same in this problem, use the formula mode. Third one is also same. Here the only you have to calculate all these terms and use the formula for mode. Now geometric mean. Geometric mean is the set of n observations is the nth root of their product. And this geometric mean is denoted by capital G. And capital G is equal to x1, x2 up to xn. That means the product of x1, x2 up to xn and their 1 by nth term is nothing but our geometric mean. For computation purpose, it is simplified as follows. G is equal to antilog of 1 upon ni summation I going from, 1 upon n into summation I going from 1 to n into log xi. Okay. There are some properties geometric mean of pooled data for two groups, their merits and demerits and their uses. Now we see the concept harmonic mean. Harmonic mean is a set of observation, none of which is zero, is the reciprocal of the arithmetic mean of the reciprocals of the given values. And this harmonic mean is represented by capital H. And this harmonic mean is given by H is equal to 1 upon Ni, summation I going from 1 to n, 1 upon xi. Now, this n in that means here we get the final answer harmonic mean is equal to n divided by summation I going from 1 to n fi divided by xi. There are some merits and demerits of harmonic mean. Their uses of harmonic mean. Now, weighted means. Weighted arithmetic mean, weighted harmonic mean, weighted geometric mean. Weighted arithmetic mean is represented by xw bar, which is given by summation wi xi divided by summation wi. And the weighted geometric mean is represented by gw, which is given by the formula antilog of summation wi log xi divided by summation wi. And the weighted harmonic mean is represented by hw and is given by summation wi divided by xi. That is their summation. There are some results. First one is, if A and B are two positive observations, then their arithmetic mean is greater than or equal to geometric mean is greater than or equal to harmonic mean. This result is important for our objective. Now, result second, if A, B and C are three positive observations, when we are given three A, B, C positive observations, then we get the equality arithmetic mean is greater than or equal to geometric mean is greater than or equal to harmonic mean. Okay. Now, if A and B are two positive observations, then the corresponding arithmetic mean, geometric mean, harmonic mean satisfy the relation. This one is also important for objective. That means geometric mean is equal to under root arithmetic mean into harmonic mean. Okay. In other words, geometric of A and B is geometric of their arithmetic mean and harmonic mean. Now we see the concept quartiles. Quartiles is the values which divide the data into 4 equal parts are known as quartiles, which is represented by capital Q. That is Q1, Q2, Q3. And this representation Q1, Q2, Q3 is represented by Q1 is less than or equal to Q2 is less than or equal to Q3. For ith quartile, for this ith quartile, Qi is equal to size of I into n plus 1 divided by 4th observation. And here the value of I is equal to 1, 2 and 3. Okay. Now, this one is Q1 is equal to L plus H by Fk In whole divided by 4 minus F minus 1 and the value of I is equal to 1, 2, 3. Here the L, Fk, H, N, Fk minus 1 is represented, Fk minus 1 is nothing but cumulative frequency, N is total frequency. Now deciles. Deciles is represented by capital D, and this one is 9 deciles, that is D1, D2 up to Dn, such that D1 is less than or equal to D2 up to less than or equal to Dn. And this Di is represented by the formula size of I into n plus 1 divided by 10th observation, and I is going from 1 to n. This is formula for Di, that is L plus H by Fk In divided by 10 minus Fk minus 1, and I is from 1 to n. Percentiles. For this percentile is represented by capital P, and these are 99 percentiles, which is represented by P1, P2 up to Pn, which is P1 is less than or equal to P2 up to less than or equal to Pn. And this is formula for Pi, that is size of I into n plus 1 divided by 100 observation, and I is from 1 to 99. This one is Pi, that is L plus H by Fk In divided by 100 minus Fk minus 1, and I is from 1 to 99. Now, graphical method of locating partition values. This one is like this. There are on x-axis class boundaries, and on y-axis there are the values of LCL. Okay. Now, in this problem, okay, we are given Q1, Q2 up to, we have, just a minute, we have to find out arithmetic mean, geometric mean, harmonic mean, median, Q1, Q2, Q1, Q2, Q3, D3, decile, D7, and percentiles P15, P70, P85, and P90. And the data are given 32 up to 38. Now we draw table, and in this table, first column is serial number, that is 1 to up to 10. Now put out the values of Xi in second column. Xi is 32, 35 up to 38, and their sum is 396. Now using log table, and when we see for value of 32, that is log of Xi is nothing but 1.50514997. Find out all these values of log Xi and put out these values in column 3. And add these terms, we get the answer 50.94416,186. Now the calculate 1 upon Xi. That means 1 upon 32. The value of 1 upon 32 is 0.03125. Okay. Calculate all these terms and add these terms, where then we get the answer 0.25633905. Now we put out the values of Xi in ascending order and add these terms. Then here already, no, 41, 43. Okay. Ascending order, then we get the answer. Add these terms, then we get the answer 396. Now for arithmetic mean, that means summation Xi divided by n, number of observation. Here the number of observation n is equal to 10. Put out the values of summation Xi and the value of n, that is 10. We get the answer 39.6. Same for geometric mean. Put out the values of Xi, and in this formula, anti-log of summation log Xi divided by n, calculate all these terms, we get the answer. For same harmonic mean, that means n divided by summation 1 upon Xi, and is nothing but 39.01083572. Now median, size of n plus 1 divided by 2th observation, that is size of 5.5th observation, this is nothing but 38.5. For quartile, Q1, Q2, Q3, use the formula for Q1, Q2, Q3 and put out these values, then we get the final answer. Same for D3 deciles, that is D3, D7 percentiles, P15, P70, P85, P90. Okay. Here just you have to calculate all these terms and use the formula. This one is same example. Okay. Quartiles. All of you solve these examples. If any queries or doubt, you call me. I'll share. Sorry. I am explaining you all these things. Okay. This one also examples are. There are some more example. 1 to up to 12. Now, measures of dispersion. In this measure of dispersion, there are some series ABC and their respective observation. Then these calculate all this addition. That means 135, 135, 135. Then we calculate the mean. Okay. Dispersion, and dispersion is nothing but dispersion is the measure of the variations of the items, and this definition is given by A.L. Pauli. And also there are some definitions, W.I. King. Now there are requirements of a good measure of dispersion, absolute and relative measure of dispersion. Now we see the concept range. Range is nothing but x maximum minus x minimum, where x maximum is nothing but the greatest observation and x minimum is nothing but our smallest observation of the variable value. This one is the formula for range. Now, coefficient of range, that is x maximum minus x minimum divided by x maximum plus x minimum. There are some merits and demerits of range. Now, quartile deviation or semi-quartile, semi-in-quartile range. For in-quartile range, Q3 minus Q1, that is quartile third, and minus quartile first. Quartile deviation is nothing but Q dot D, which is equal to 1 by 2 into Q3 minus Q1. Now, coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1. And this Qi is equal to L plus H divided by Fk into In divided by 4 minus Fk minus 1, and I is nothing but 1, 2, 3. And when we use this formula, we get the values of Q1, Q2 and Q3. Merits and demerits of quartile deviation, mean deviation. Now, computation of mean deviation. Computation of mean deviation is represented by MD, that is mean deviation, M dot D. And this is given by the formula and 1 by N summation I going from 1 to N into mod of Xi minus A, where summation I going from 1 to N Xi minus A is the sum of absolute deviation. A is nothing but A is any one of the averages, mean Xi, median, MD, and mode is denoted by M0. And this MD, that means mean deviation, is given by summation I going from 1 to N Fi. Mean deviation above mean, that means for individual observation, we get the formula summation I going from 1 to N mod Xi minus X bar divided by N. And this is for frequency distribution, summation I going from 1 to N Fi into Xi minus X bar divided by N. And this N is nothing but our summation Fi, that means mean. This one is mean deviation about median, and this one is represented by MD, and this is given by for individual observation summation I going from 1 to N Xi minus MD divided by N, And for frequency distribution, MD, that is mean deviation about median, is given by summation I going from 1 to n Fi into mod of xi minus MD divided by n. Mean deviation about mode. This one is represented by M0, MD or MO. And this one for individual observation, this is given by the formula summation I going from 1 to n mod xi minus mo divided by n. And for frequency distribution, summation I going from 1 to n Fi into xi minus mo divided by n. There are some example. First one is, there are values 2, 3, 7, 8, 10. Now x bar, MD, and put out these values xi minus x bar. Then we get the value of MD, that is mean deviation. Now minimal property of mean deviation. This coefficient of mean deviation is nothing but our mean deviation divided by average about which is calculated. That is MD of x bar divided by x bar. And for coefficient of mean deviation about mode, this one is represented by mean deviation into MD divided by MD. And the coefficient of MD, M0, is equal to MD mean deviation of mode MO divided by MO, that is mode. There are some merits and some demerits of mean deviation. Now we see the concept mean square deviation. Mean square deviation is represented by MSD, and this one is formula for MSD is nothing but 1 upon n summation I going from 1 to n into xi minus a bracket square. And in case of frequency distribution, that means here the values of xi and fi, then we use the formula MSD. That means mean square deviation is equal to 1 upon capital N, which is nothing but n is summation I going from 1 to n, the value of fi, into summation I going from 1 to n fi into xi minus a whole bracket square. Okay. Now we see the main and important concept, that means variance. Okay. This one, variance is represented by capital V. Capital V of x is equal to sigma. This is symbol for sigma. Sigma x square. That is nothing but 1 upon n summation I going from 1 to n xi minus x bar bracket square. Okay. And for frequency distribution, variance is represented by V of x and is given by the formula 1 upon n summation I going from 1 to n fi xi square minus x bar square. There are some merits, demerits of variance. Also, there is effect of change of origin and scale on variance. The variance is invariant to the change of origin but variant to the change of scale. Y is equal to now combined variance. Whenever we get two series of observations and we have to calculate the variance, then use this formula sigma square is equal to n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square whole divided by n1 plus n2. And d1 is nothing but our x1 bar minus x bar, d2 is x2 bar minus x bar, and x bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Now we see the concept standard deviation. Standard deviation is represented by SD, and the symbolic, this is represented by sigma x, and sigma standard deviation is nothing but under root of variance of x. This is plus sigma square x square. Okay. And for frequency distribution, standard deviation is nothing but under root 1 upon capital N summation I going from 1 to n fi xi minus x bar whole bracket square, where x bar is equal to 1 upon n summation I going from 1 to n fi xi. There are some merits and demerits of standard deviation. For any frequency distribution, standard deviation is greater than or equal to mean deviation above mean. Okay. Now, standard deviation of combined series. This is represented by sigma is equal to by this formula n1 under root n1 sigma 1 square d1 square up to nk sigma k square dk square whole divided by n1 n2 up to nk. Okay. For calculating standard deviation of combined series, use this formula. Now, coefficient of variation. This is represented by C dot V, that is coefficient of variation, and is given by the formula standard deviation divided by mean into 100. Standard deviation is represented by sigma x divided by x bar into 100. Okay. Now, in this problem, we have to find out range, quartile deviation, mean deviation, about mean, standard deviation, and coefficient of variation for the given data 43 up to 88. Okay. We have to prepare a table. For this table, we first column is serial number 1 to up to 8. Put out the values of xi in second column, that is 43, 42 up to 88. Add all these terms, we get the final answer 400. That is the sum of xi. Now calculate xi square, that is 43 square is nothing but 1849. 42 square is 1764. Add all these terms, we get summation xi square is equal to 23744. Now calculate mod of xi minus mu. Calculate all these terms, that is xi minus mu is nothing but our 7, 8 up to 38. Add these terms, we get 140 xi dash. Now use the formula for range, that is x maximum minus x minimum. X maximum is what? 88 and x minimum, that means 12. 88 minus 12, 76. Now arithmetic mean, that is mu, is represented by mu summation xi divided by n. Summation xi is nothing but our 400. 400 and the value of n is our 8. That is 400 divided by 8 is nothing but 50. Put out all these values, formula for variance, standard deviation, mean deviation, quartile deviation, Q1, Q2, Q3. You just calculate all these terms and we get you are all these terms and then we get the answer. Okay. This one is for frequency, when the frequencies are given. Okay. Here are some classes and their respective frequencies. Here also we have to prepare the table. For this table, column serial number LL, that is means that lower limit, upper limit, Fi, Xi, calculate the value of Fi into mod of Xi minus MD, Fi Xi square, and cumulative frequency CM. Okay, here for this class, lower limit, that means the value of lower limit is 10. For this class, upper limit is 15. Put out all these terms in LL, that is lower limit, upper limit. Frequency, respective frequency is Fi. Okay. Okay. You just put out all these values in this formula, you get the final answer. Okay. This one is the same. Sigma for combined series. Cumulative variation. This is our objective. Now, these are some questions are there. What is dispersion? Define coefficient of variation. State any two uses of it. Just calculate, and there are some problems. There are also given answers of these questions. Okay. सुप्रिया खोत व्हॅल्यू काढण्यासाठी लॉग टेबल वापरायचा का? हो हो. तुमचे जिथं तुम्हाला आता जिओमेट्रिक मीन वगैरे आहे तिथं तुम्हाला लॉग टेबल किंवा अँटी लॉग काढायचं आहे, तिथं तुम्हाला कंपल्सरी लॉग टेबल वापरायचं आहे. तुम्ही ह्या आधी सुद्धा केलेले आहेत, लॉग टेबल वापरलेले आहेत. Shall we get the last year? Okay, I'll try it.
Hello,
Is calculator available allowed? Yes, there is
ma'am.
allowed. तुम्हाला तिथं कॅल्क्युलेटर वापरू देतात.
Hello. Hello.
हो, कॅल्क्युलेटर वापरू देतात तुम्हाला, अलाउड आहे. आणि कुणाला काही शंका असेल तर विचारा.
Hello.
तुमच्या कमलाकर सर आहेत ना, त्यांना हे करा, कॉन्टॅक्ट करा, ते देतील तुम्हाला.
Hello, ma'am.
म्हणजे आता प्रॉब्लेम सगळे शिकवलेले आहे ते तुम्ही स्वतः पहिल्यांदा सॉल्व्ह करा. त्याच्यामध्ये काही जर प्रॉब्लेम येत असेल तर कॉल करा, मी सांगते तुम्हाला.
रमा बोला ना रुमा.
Sir, scientific calce allowed आहे का?
About regarding offline lecture, contacted to कमलाकर सर.
मॅडम लास्ट इयर क्वेश्चन पेपर मिळतील का?
आपण नेक्स्ट लेक्चर पासून डिजिटल स्लेटचं जरा बघूया. त्या ह्याच्यामध्ये काय प्रॉब्लेम झालेला होत नव्हतं, त्यामुळे स्लेटला जरा रिप्रेझेंटेशन आपल्याला ऑफलाईन लेक्चर घेतल्यासारखंच होईल. अजून कुणाला काही शंका वगैरे आहे?
मॅडम क्वेश्चन पेपर
नसेल तर
बद्दल.
आपण थांबू इथे.
हॅलो.
ओके.
हॅलो मॅडम. हॅलो. हॅलो. हॅलो.
Okay, thank you all of you. Good day.